welcome back, everybody. So we're going to be going over this homework from Section 7.7, Day 2. Remember, we didn't learn a lot of new stuff with that Section 7.7, Day 2. It was just more of like going over problems, additional ones, and how to do. Now, remember that just to kind of talk through the agenda for today, or for this week, excuse me. I know we got to kind of have a weird week now with no school Monday, no school Friday. So we got a 3-day week. That's nice for you guys, right? 3-day week. So snow day yesterday. We got section 7.8 today, which is a lot, which again is not any new material. You're going to find we do have some guided notes to do, but I'll tell you what, I could give you this guided, if you did your homework, I could give you this guided notes right now and you'd be able to do everything. Okay. Section 7.8, that's not too bad. And then tonight's homework will actually be the practice test. We're going to go over it tomorrow and then test on Thursday. So it actually works out kind of nice for us. We just finish it off and we're going to do our test on Thursday. Okay. And then we can start into chapter 8 next week. Yeah, start into chapter 8 next week. Here's what I will say though. I want to remind you, I want to stress to you, the chapter 7 test is one of the biggest grades of the third 9 weeks. Okay, I'm not trying to scare you at all, but I'm trying to kind of give you guys a little bit of a wake-up call and say, maybe I need to study a little bit harder for this stuff. Okay, this is a very important grade out of the third 9 weeks. We are going to be doing chapter 7 and chapter 8 within the third 9 weeks. So there's going to be one other big grade in this chapter, the chapter 8 test. You got the chapter 7 test and the chapter 8 test. I'm not saying there won't be other quizzes. There will definitely be other quizzes that will go into some of the grade books. But in terms of tests, in terms of large grades, this is one of the biggest grades out of the third 9 weeks. So please plan accordingly, okay? All right, so let's get to it. We've got number 26. This is evens, right? Evens, not odds, evens? Evens. Okay. Number 26. Carson, you got the first one up here. What'd you get for 26?
24x7.
Good, 24x to the 7th. Very good. Now, again, I'm going to be stopping periodically throughout. If you want to go over any one of them, circle it, and we'll go over it on the whiteboard together. Again, that was 24x to the 7th.
Did you start your video?
I did. Thank you, though. Rosalie, what'd you get for 28?
7.5x to the 3rd, y to the 5th, plus c to the 7th.
I like all of the variables. X to the 3rd, y to the 5th, z to the 7th. Make sure there's a plus sign in at the end of that. But I've got 5. 5. Oh, I think, you know what I think you did? I think you did 1/2 instead of 1/3. Because you said 7.5? Yeah, that's half of 15, not 1/3 of 15. Should have been 5 at the beginning. Again, all you do, again, if there's no plus or minus signs like 28, 30, 32, 34, is just multiply common pieces together. Multiply the numbers, multiply the letters. Number 30. Joey, what'd you get for 30?
-12 x to the 5th, y to the 3rd.
Good. -12 x to the 5th, y to the 3rd. Number 32. Alex, what'd you get for 32?
14x to the 6th and y to the 7th.
Very good. 14x to the 6th, y to the 7th. Very good. Ben, what did you get for 34?
24m to the 4th, and then n to the 4th.
Very good. Let's pause here at the end of 34. Are there any questions through 34 that we want to go through? Any questions through 34 that we want to go through? No? Okay, cool. Then let's start here with 36. Number 36. What'd you get for 36, Mr. Schrumbach? Good. 18x to the 2nd minus 45x. Very good. 18x to the 2nd minus 45x. John, what did you get for number 38?
I got 33x to the 3rd. Or that might be a y.
Is that all? For number 38?
That's what I have.
Uh-oh. How'd you get 33? Oh, you can't combine like terms. What did you have on the step directly above that?
6x plus 15x plus 12.
Okay, that's your answer. Don't combine. but it should say 6x squared plus 15x plus 12. So you did it right. You can't combine like terms because they're not like terms. Does that make sense? Again, the final answer for 38 was 6x squared plus 15x plus 12. Berkeley, what'd you get for 40?
30x to the 5th, y to the 4th, plus 5x to the 4th, y to the 6th.
Yes, that is probably one of the more difficult questions on the homework. What we would do for that one, I'm just going to talk through that one because, again, that was a lot of, I think I tried to give you a little pointer on number 40 when you guys were doing it in class on Friday. But we got x to the 2nd, y to the 3rd times 5x squared y, all times 6x plus y squared. I said multiply the things on the outside and then distribute it in. So if I multiply this stuff on the outside, that would be a 5x to the 4th, y to the 4th. And then we bring it in 6x plus y squared. So when I distribute that in, that's, okay, 5 times 6 is 30, x to the 5th, y to the 4th. And then here, plus 5x to the 4th, y to the 5th. When we leave that, those are not like terms, so we cannot combine those. All right, good. Number 42, Hayden Rudder, what'd you get for 42?
I got a to the 5th, b to the 6th.
Just that, a to the 5th, b to the 6th?
And 1a was b to the 5th.
Oh, you added, I think, Hayden. When you distribute in, you can't add, you got to multiply.
Okay.
Yeah. So what do you get when you take? Oh, oh, please. I hate when I do this. At the end of each class, I come back here with my pen and I leave it. All right, this is 42, correct?
Yeah.
Yeah. Hey, number 42. When I multiply this in, I'm going to rewrite it out here. Negative 2a squared b to the 3rd times 3ab squared minus a squared b. When I multiply this in, I'm going to take negative 2 times positive 3. Negative 6. I'm going to take a squared times a to the 1st. What do I get? And then I'm going to take b to the 3rd times b to the 2nd. Good. And then I take this whole piece and multiply it over here. So negative 2 times negative 1, that turns into a plus 2. A squared times a squared. What do I get? And then I have b to the 3rd times b to the 1st. What do I get? And you leave that like that, because they're not like terms. Does that make sense? Okay, that's number 42. Number 44, Taylor, what'd you get for 44? It should be x squared plus 2x minus 15. I think you know what you did? You wrote it down as x plus 5, x plus 3, didn't you? It's x plus 5, x minus 3. Okay, x plus 5, x minus 3. When you do that, some of them turn out to be negative. So let me go over this one real quick for everybody, just so we remember how to FOIL. This is a good time to kind of pause and remind us how to FOIL. Remember, you go first, outer, inner, last. And then you combine like terms in the middle. X squared plus 2x minus 15. Number 46. What did you get for 46, Will?
That would be m squared and minus 25.
No. No. You didn't do your homework, did you?
Well, I did most of it. It's not that
Did you do? Okay, read me your answer for 30 then. No, okay, then read me your answer for 39. Then read me your answer for 27. Thank you. See, don't lie to me. Just say you didn't do it. I'd rather you be honest. Let's take a look at 46. I've got m minus 5 and then m minus 5. I take m's together. M times negative 5 is a negative 5m. Negative 5 times m is a negative 5m. and then negative 5 times negative 5 is a positive 25. I combine like terms in the middle. I should get m squared minus 10m plus 25. And there's my answer. It's for 46. What did we get for 48? Serenity, what did you get for 48? Read that for me. 9x squared minus 24x plus what? Should be 16. Should be 16. But the correct answer, again, you might have just written it down wrong. 9x squared minus 24x plus 16 for number 48. And I've got to jump to line out of the top. A 26. Tag right there. Okay, number 50. 7, there it is. 50. What'd you get for 50? Baker's out here. What'd you get for 50? Liam, not here. What'd you get for 50? Travis, here.
X squared minus 2x plus 2.
Oh, you're so close. My x squared minus 3x plus 2. Yeah, you should have gotten a negative 1x and a negative 2x to make minus 3x. Number 52, Mackenzie.
I forgot to do the
The FOIL method?
yeah.
Let's do it real quick then.
Okay.
Let me get this out of the way. 52. I've got 2x plus 7 and then 3x plus 7. All right. So what's 2x times 3x? 6x what?
Squared.
Yeah. 2x times 7.
14.
7 times 3x.
21.
7 times 7. 49. I'll help you out. It's before 9 o'clock. And then we combine like terms in the middle. 6x squared plus 35x plus 49. Does that make sense?
Yeah.
54. Now 54, 56, 58, and 60. These next 4 problems can get very, 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 very tricky. Okay? Nevaeh, what did you get for 54?
I got negative 8x plus 4 plus 80.
Let's check that one. Let's go through that one. Let me just write it down. I've got 2x plus 5. And then x squared minus 4x plus 3. Okay, Nevaeh. I'm going to bring in this 2x here. What's 2x times x squared?
2x plus 4.
Good. What's 2x times negative 4x?
Negative 8x squared.
Good. And then 2x times 3. Very good. Okay, we're good there. What's 5 times x squared? Yeah. What's 5 times negative 4x? Good. And what's 5 times 3? Good. Okay, now at that point we just combine like terms. So here we just say, okay, 2x cubed minus 3x squared minus 14x plus 50. Does that make sense?
So what did I do?
I have no idea.
Everything wrong.
Yeah, I'm not really sure what you did. I was gonna try to read through what you did, but I don't know. I really don't know. Hannah Neely, what did you get for number 56?
X to the third minus 8x plus 21x minus 18.
Very good. Yes, that is correct answer for number 56. I'm going to read that one more time. X to the third minus 8x squared plus 21x minus 18. Very good. Number 58. Okay, I want to go over 58. I want to do 58. X minus 4 to the third. X minus 4 to the third power. Now, when you take x minus 4 to the third power, can I just distribute in the third power? No, you can't do that. So here's what I do. Again, you say x minus 4 times x minus 4 times x minus 4. We did this one time on our guided notes. That's why I want to kind of go through it with just me here. Okay, bring in, you know what, let's multiply these on the other side. Remember, these are the ones where I like to go on the right side and then multiply in. I've got x minus 4 straight down here. This is going to give me an x squared minus 4x. And then a minus 4x. That's not a 4, that's a 2. Minus 4x and then plus 16. So all in total, x squared minus 8x plus 16. And now I have to multiply in the x minus 4. I have to do x cubed minus 8x squared plus 16x. And then do a negative 4x squared plus 32x minus 4 times 16. 64. And then we combine like terms. Looks like I've got an x to the third minus 12x squared plus 48x minus 64. That one was a hard one. That was a difficult one. Okay, and then the last one here, we've got number 60. I'll just go over this one here as well. We multiply in with the 2x. 2x times 4 is 8x. 2x times x. Oh, sorry, negative 2x. Negative 2x squared. And then 2x times 6x to the third is a 12x to the fourth. And then I do the same thing here. Plus 40 minus 10x plus 60x to the third. Now here's the tricky part about this one. There's only one set of like terms. So my final answer is going to be 12, forgot, standard form, highest power, x to the fourth, plus 60x to the third. Now those are gone away. And then I've got a minus 2x squared, nothing left with that. 8x and negative 10x, that's the only thing I can combine to get a minus 2x. And then plus 40. And that's my answer. Questions on that? Okay. So how did we do on that? Did we do okay? Yeah? Hopefully we at least did it, which is an improvement upon the last homework, right? So here's what we're going to do today. I just want to go through some, this is technically section 7.8. Section 7.8 is special products of binomials. Basically just saying, okay, are there any tricks? Are there any shortcuts that we can take to find products of binomials? Now, product, again, means to multiply. So product of binomials, I'm only taking just binomials. Is there any shortcuts I can have when it's just a binomial? That's what we're going to be looking at today. Now, when we're multiplying with binomials, remember that that's the FOIL method, right? So, out of everything I teach you today, could you possibly just keep doing the FOIL method? Of course. The FOIL method works. If you like the FOIL method, you keep using the FOIL method. That's perfect. Okay. But I know some of you guys might like to learn some tricks, some shortcuts. Now, we talked about the FOIL method where it's first, outer, inner, last, right? First, outer, inner, last. Now, what happens again if it's a binomial square? We looked at it on the homework, and we looked at it on Friday in the notes, or Thursday and Friday with the notes, is that if I've got a binomial squared, the inner two pieces are always going to be the same value. They're always going to be the same value. So what we can say is the shortcut is that you can square both pieces and put them on the outside, and then the inner piece is double the product. Okay? My Algebra 1 teacher taught us to say squared, double the product, squared. Squared, double the product, squared. Now, could you just do the FOIL method? Of course, that's completely fine. Okay? This is what's called a perfect square trinomial. One that it's a perfect square, something that you take a a part times part, and you square it, and it's itself. Now, you don't necessarily need to know that term and know that it's a perfect square trinomial, but we'll use that fact a little bit later on. All right, so we got x plus 3 squared. Let's do our standard FOIL method, and then I'll show you the trick. Let's do our standard FOIL method. But what we have to do here is say that okay, I've got an x plus 3 times an x plus 3. So if you're on your test on Thursday and you're saying, man, what do I do here? Isn't this a trick? And you don't remember, just use FOIL. X times x, x times 3. 3 times x, 3 times 3. Everybody follow me there? Hopefully this distributed property, that FOILing method, is like this now. Now that you've done all of these homework assignments, it should be very easy now. And now we just combine like terms. What is unique about this? Well, the inners and outers are the exact same thing. X squared plus 6x plus 9. And that's my answer. X squared plus 6x plus 9. Now, okay, so what's my trick? Well, I square x, I get x squared. I square 3, I get 9. Notice how my x squared and 9 are on my outside? Well, how do you get my inside? Well, what's the product between x and 3? 3x. Double it, 6x. Squared, double the product, squared. Like I can tell you right now, the answer for this problem, without even foiling, is 16s squared. Product is 12st, so double it, 24st, and I squared 3t. Okay, 3 squared is 9, t squared. I know right now that that's my answer because I know the shortcut. How do we do it without the shortcut? Well, we can FOIL it. 4s plus 3t, 4s plus 3t. Okay, let's FOIL it. 4s times 4s, 16s squared. 4s times 3t, 12st. 3t times 4s, 12st. 3t times 3t, 9t squared. When I combine like terms in the middle, I get 24. 16s squared plus 24st plus 9t squared. See, it's a trick. It's just a very easy way to square a binomial. Square a binomial. Again, that squared product squared, it only works when it's a binomial squared. All right, so the next special product is, oh, we got some more on there. I didn't even see that. Oh, it's the same thing. Let's do that again. 4m minus 10 squared. See, I know right away with my trick, the answer is going to be, well, square, 16m squared. The product of these two things is a negative 10 times 4 is a negative 40. Double it, negative 80. And then square negative 10, I get a positive 100. See, I know right away that that's going to be my answer because I know that trick. Well, how do we get there without it? Well, we just FOIL it. So we take 4m times 4m, 16m squared. We take 4m times negative 10, negative 40m. We take negative 10 times 4, negative 40m. We take negative 10 times negative 10. We get positive 100. So when I do my first outer and the last, I see again that my inner two terms are exactly the same. So I say 16m squared minus 80m plus 100. And that's my answer, which confirms what I got with my trick. Try to do the last problem there on your own. 7 minus r to the third squared. 7 minus r to the third squared. Okay, so this is 7 minus r to the third times 7 minus r to the third. Let's FOIL this. 7 times 7. 7 times negative r to the third. Negative 7r to the third. And then do the same thing. Negative r to the third times 7. Negative 7r to the third. Now, what do I get when I take negative r to the third times negative r to the third? Well, what's a negative times a negative? Positive. And now, what is r to the third times r to the third? R to the 6th. Not r to the 9th. Remember, when I multiply with like bases, I add exponents. So I'm going to combine like terms in the middle again. I'm going to have 49 minus 14, r to the third plus r to the 6th. And I guess if I'm being really picky, I would put this in standard form. I would say r to the 6th minus 14 r to the third plus 49. But we can just leave it right there for our purposes today. So that's one special product. When I've got a two-term squared, look, squared, double the product, squared. The other type of special product is when I have something like this. What do you notice about these two binomials? Good. They're the exact same thing, but the signs are switched. They're the exact same things, but the signs are switched. So this is a special product. Let's see what happens when we FOIL it out. X times x, what do we get? X squared. X times negative 4. Negative 4x. Okay, nothing fancy yet. 4 times x. 4 times negative 4. What's going to happen? What's going to happen? They're going to cancel out. The negative 4x and the positive 4x are going to cancel out. That's why this is a special product. So how did we know that was going to happen? Well, we knew that was going to happen because we saw the same thing in our parentheses, except one was a minus, one was a plus. Okay, that's how we knew that it was going to cancel out. This, my friends, is called a difference of squares. A difference of squares. The signs are different, and they end up being perfect squares. X squared, 16. So let's try that again. 10 plus b, 10 minus b. Isn't this set up the exact same way? Same exact thing in parentheses? Just one's a plus, one's a minus? So let's try to FOIL this out. 10 times 10, 100. 10 times negative b, negative 10b. b times 10, positive 10b. b times negative b, negative b to the second. What happens again? They cancel. My inner two terms cancel. Leaving us with a 100 minus b squared. And again, we'll just leave it like that for our purposes right now. I know technically standard form tells us we should say negative b squared plus 100, but okay, let's try one more of those. Is this that same format? Yeah, same exact thing in the parentheses, just different signs. What's p squared times p squared? P to the 4th. P squared times negative 8q. Well, that's negative 8 p squared q. Be careful there. I like to put it in alphabetical order. I'll put the p's first. Since we're multiplying, we can put it in any order. And now we do the same thing here. 8q times p squared. So that's plus 8p squared 8q. 8q times negative 8q, negative 64 q to the second. Does this cancel again? Yeah. So it doesn't really matter what's on the inside of my like two values there. They're going to cancel. P to the fourth minus 64 q squared. That's my answer. Okay. Those are just unique types of products. Unique types of products. So that's really it for section 7-8. So what you have on the back side of your guided notes is a memory refresher. Remember all the way back when we did section 7-1 to 7-4, we had all of these rules. We knew these. Well, some of us did. Most of us did. We knew these. We knew these rules like it was nothing. So let's go back and try to refresh our memory a little bit, because again, the test is on Wednesday. We gotta review our rules. What is a to the 0 power? What's anything to the 0 power? 1. Okay. So that means, you know, 1. So that means 31.8x to the 0? 1. Okay, what happens when you have a negative exponent on something? Where does it go? To the bottom, right? It takes the elevator down, and it's a 1 over the positive exponent. So for example, now, does the 2 move down? No, the 2 stays on top. The x to the third moves down. And the 2 stays on top because it did not have a negative exponent acting on it. Okay, what if the negative exponent is already in the denominator? Where does it go? Up to the top. Takes the elevator up. So this would just be a to the nth power. So for example here, this is the ones where we said, okay, if it's not happy where it is, change its location. A to the negative fourth. Is A happy? No, move it down. Is C happy? No, move it up. Is D happy? Leave it. And then we started multiplying with our bases. What's the rule? Multiplying with our bases does what within the exponents? Addition. Addition. A to the m times a to the n is a to the m plus n. There's addition up in the exponent. So that, what does that mean in terms of this problem over here? Well, this would be f to the 3 plus negative 7. Negative fourth. G to the 1 and 5 make 6. Now, could I leave that as my answer? There's a negative exponent there. Where does the f go? To the bottom. G to the 6th over f to the 4th. Remember, the only time you would leave a negative exponent is if it's a scientific notation. Let's keep going. What do I do when it's a power to a power? You multiply. That's distribute down here. You multiply a to the m times n. So that means over here, this would be m to the 6 times 4 is 24. This next one is where I distribute. Yes, I do distribute the power there. I know I was telling you not to do that earlier today. Well, that's because there was an addition or subtraction sign in there. If there's no addition or subtraction signs in there, yeah, distribute the power. This would be a to the n times b to the n. So for example here, this is negative 2 to the second is positive 4. X to the third to the second is x to the 6th. Y to the second. Everybody gets the 2. What's the rule for division? What do I do with the exponents when I'm dividing with my bases? Subtraction. Good. A to the m over a to the n is a to the m minus n. So in this case, I've got x to the third, y to the negative 6th, right? 1 minus 7 is negative 6. And then I bring down my y, x to the third over y to the 6th. And then my quotient rule is the exact same thing as my product rule. I distribute in that power. A to the n, b to the n. A to the n over b to the n. So if I'm looking at this example over here, I would take 2 to the 4th, or 16, n to the 3rd to the 4th, multiply, n to the 12th, m to the 2nd to the 4th, m to the 8th. What happens when you have a negative exponent on a fraction? What does it do to that fraction? It flips it. So this would be b over a raised to the positive nth power, and then we distribute it in. So for example here, this would be 3 over x to the 6th raised to the positive 3rd power. Right, I flip the fraction on the inside, and then I raise it to the positive, and now I distribute in. 3 to the 3rd is 27, x to the 6th to the 3rd is x to the 18th. Okay, I hope that refreshes our memory a little bit so that we could do this practice test. I normally like to give you some time to work on a practice testing class, but I thought it was beneficial to go through that with you guys. There it is. There's your practice test. Okay, so what do we say about practice tests? Double homework points, right? Always double homework points, and on a separate sheet of paper, please. Because remember, you're going to come in tomorrow, we're going to go through every single one of these problems, and then you should be making yourself a key tomorrow. Like an answer key. So again, work to the bell, please. Ooh, I gotta stop my video. Completely forgot. So long, everybody at home.